我们高铁在明天晚上我们有个抽奖活动，这个是张免费高铁，6张半票高铁，就是说要抽奖，这个是我们。 特别请郑总来，因为他是 MIT 毕业的，那他来介绍我们的 speaker 这名正言顺，因为他们从 MIT 过来。好，那我们现在就请郑总，谢谢。
Chairperson, Mr. Professor Song, and also co-chair, Professor Hong, and distinguished keynote speaker, and also the keynote distinguished guests from various foreign countries, and ladies and gentlemen, 还有各位我们台湾的长官朋友，大家早安。好。As Mr. Hong has introduced, I am the Jen, and now I am the president of Taiwan High-Speed Rail, and I am graduate from MIT in 1984. So today is my greatest pleasure and honor to be a moderator to introduce our alumni. Professor Hal Abelson. I have some small note to brief you our alumni, Mr. Professor Hall. Yeah, Dr. Hall was born in 1947. He got his bachelor's degree from Princeton University and got a PhD degree in mathematics from MIT. Now he is a professor of the Department of Electronic Engineering and Computer Science at MIT, and he is also a fellow of the IEEE. Professor got a lot of the awards in recognition of his significant and substantial contribution to teaching and academic education. He was a recipient of the various awards in computer science education and outstanding educators in 1992, 94, 5, and 2011, 2012 from MIT, IEEE, and other institutions. We know that Professor Hall had various outstanding performance and achievement, but here I would like to point to the most important outstanding achievement. One is Professor Hall endeavor to computer science education for the university student. Together with MIT colleague, Garland, Susan, and Abelson developed the computer science subject, structure and the implementation of computer program, which is organized around the notion and computer language is primarily a formal medium for expressing ideas about methodology, rather than just a way to get a computer for perform operation. This subject has been a big worldwide impact on university computer science education and served now as MIT's own introductory computer science subject from 1980 to 27. The other outstanding achievement I would like to point out is Professor Hall did his best to initiate App Democracy and MIT Apps Inventor. The most important concept of MIT Apps Inventor is to put the power of making this app to the hands of everyone, but not the hands of just a few professionals and corporations. The vision of the application is not just the one about application. It's not just one of teaching people how to make programs. It's ensuring that and this technology can continue to shape our life. What is the computational thinking? More detail will be introduced in our professor, but at the moment I will say you, computational thinking is the best thinking practice to solve problems for students. And it is the way we can use programming as a tool for understanding things. It's a digital scale for everyone, and we can use computational thinking and the technology power to innovate solutions to improve our quality of life. And what is the computational action? The outcome that equipped with the capability of the computational thinking plus the power of computing, it creates innovation and a helpful solution to make life better. The best practice is our professor Hall usually describe and very impressive best practice of this application of App Inventor. Yes, there is a group of high school students in the Republic of Moldova in Eastern Europe wrote an app which allows people in their country to identify information about where water is clean or where water is polluted. Share that the whole country is now building resources where you can get pure water. It means the high school students make a big contribution to their community and to the country by using App Inventor and map computational thinking to computational action. So, from about my brief expression, our professor Hal Abelson is absolutely an outstanding educator, and he is a vision in the computer science field. Now, let us welcome Professor Hall, and with the warm applause for his speech. Computational action. Okay, welcome.
You put up the next slide. 那个下一个 slide。用。他的 slide 呢？ Can someone put up the next slide? Okay, thank you. Thank you for inviting me. It's okay? Oh, yeah. Okay, that's working now? Okay, thank you. So thank you for inviting me to Taiwan. Thank you, Chairman James, for that too complimentary introduction. I hope my talk can live up to it.
I'm going to be talking about computing and education. First of all, are there any teachers in the audience? Ah, good. Right, this talk is for you. This is about the opportunity of computing to really inspire and empower young people. I arrived at MIT as a graduate student in 1969, and I was lucky enough when I got there to meet a professor named Seymour Papert, who I think some of you have heard of. Seymour Papert was the genius who was the first one to articulate the idea that learning to express things in computational terms, learning to create programs that could instruct computers. Papert was the first one really to express the idea that that could be something that had real educational value. It's very hard to put your mind back, now almost 50 years, to what computing meant. Right? It's almost impossible. Right? 50 years ago, computers were things that cost $1 million. They were used by the military, they were used by large companies, and they were mostly used for data processing and record keeping in companies, and for weapons calculations in industry. Papert wrote, I think, the key introductory paper in 1971 called Teaching Children Thinking. And it was about thinking, right? And it started by him saying, I'd like to propose a new kind of educational system whose key ideas was to give children a greater mastery and a sense of the power of knowledge and a self-confidently realistic image of themselves as intellectual agents. Because again, if you think about what computers in education were about in 1971, when this paper came out, it was mostly about data processing and scoring exams. And Papert liked to say, that is getting the computers to control the students, and what we need to do is get the students to control the computers. That started a project at MIT called the Logo Project, and our motto over the 1970s was computers are for kids. And everyone simply thought we were insane, because everyone knew that computers cost $1 million, and the idea that we would take these very expensive computers at the MIT Artificial Intelligence Laboratory and hook them up by phone lines so that 11-year-olds could do things like drive this robot turtle and play with them. People almost didn't pay attention to us. They thought we were just mad. But that started the Logo Project that went for 10 years. Eventually, it became more real in the 1980s when personal computers came out. One of the first ones was the Apple II, and I wrote a book explaining the Logo language for Apple, and people started to pay attention now. It seemed that it would be possible. Then, as Professor Jung mentioned, my colleague Jerry Sussman and I created what was the introductory computing course at MIT, as he told you, from 1980 to 2007. And the motto of that was that programming was a way of expressing ideas, not so much getting a computer to perform actions. And you can see from what we said here that this comes directly out of what Papert had written around 1970. So that was a thread that started with Logo, that went through computing education. Almost everyone at MIT, for those 15 years who majored in either computer science or electrical engineering, took this course. Mitchell Resnick, who's now a senior professor at MIT, showed up at MIT at the end of the 1970s, and again, out of the same stream of Logo, invented Scratch, whose theme was that even very young children can be creative with computers. Scratch is now, I think, the most widely used introduction to computing for very young children. Another person who took that course as an MIT freshman when she arrived at MIT was Jeanette Wing, who got this idea from the same stream of thinking. She eventually went on to be head of the computer science department at Carnegie Mellon University, and then director of the U.S. National Science Foundation Computer Science sector, and later became head of research at Microsoft. But when she was at the National Science Foundation, wrote a very important paper called Computational Thinking. And that's really the genesis of the word that we hear so much today. Much of what you hear today about computing and education is wrapped around computational thinking. And what Jeanette said was that this was these habits, these things that people did in writing computer programs were really very important elements of thinking that everyone should know. This paper actually had very little influence when it came out. Again, because even in 2006, the idea that everyone should be learning about computing seemed very, very revolutionary. That's not the way it is today. One of the themes I want to say in this talk is for you to realize how rapidly things are changing. So by about 2008, people realized that it was practical to spread computers out very widely, and Jeanette's words, computational thinking, are now used over and over and over again in curriculum and schools and national standards. But that's only very recent. What's in computational thinking? There's this notion that there's some very important ideas, and if you go and read the national standards about what ought to be in a computing curriculum, you get a list of ideas like sequencing and events and loops and parallelism and conditionals and operators and data and iteration and recursion and more and more and more. That's not what Papert was talking about. He wasn't talking about the elements of the computer language. He was talking about empowering young people as intellectual agents. And when I think about ideas of computational thinking, I think the most important idea in welcoming students to this new era of digital technology is that they should understand to know what's worth making. And so I tend these days not to talk about computational thinking, but rather to talk about something I call computational action. Computational action says, how can I take this power? How can I, even as a child, take this power and have an influence on the world? How can I shape this wonderful technology to do things that come from my ambition and my imagination? Let me give you an example. So Dharavi is one of the largest slums in Asia outside of Mumbai. It's home to about 1 million people. The average income in Dharavi goes from something like $500 a year to maybe 3 times that a year. Dharavi is also home to the Dharavi Code Girls. This is a group of kids, right? Girls for Change, ages 12 through 15 or 16. And what they are doing is they are using technology to build things to improve the lives of their community in Dharavi. Right? These are, again, young kids, 12 through 16. One of the things that they've built is an app, right, called Pani, which means water in that language. And what Pani does is it schedules your family's time at the community water distribution center so that people don't have to fight over it and they can be scheduled. And from there, and of course they're the young girls, they're the girls who would have to be doing the fighting and standing in the center. So they think about how this really improves the lives of the people around them. Pani is an example of computational action, right? It demonstrates how kids in even the poorest communities can start using this technology to have an impact on the lives of people around them. It's a remarkable change, and I'll keep coming back to this point, that simply was not possible even 5 years ago. And we have to appreciate how things have changed. Here's another example. Professor Jung already mentioned this one. This is the Eastern European country of Moldova, which, among other things, has a problem with pure water and has a large incidence of hepatitis B. Again, a group of high school students were in Moldova, 4 high school girls, wrote an app to help people learn about good sources of water. What you do is you're around Moldova, you find a source of water, you take a picture of it with your mobile phone camera, you fill out a questionnaire that talks about the quality of the water, and then what they've done is they've put that on a map of the country that shows where the good sources of water are. And if now you were driving around in Moldova, you can find where good water is. And again, this is another example of computational action. Right? They've set up a national resource, a national map, right, for high school girls. Right? This is computational action. It shows that even children can create a valuable resource of national scope. And again, this would not have been possible 5 years ago. And it's because on the internet right now, there are tools that say things. Can I make a map? Can I make a map that I can distribute over my community, over my country, or over the world? And young kids can now do this. We are in a different place in education and computing than we were even 5 years ago. Here's another example from the US. This is a middle school student in Kentucky who wrote, for those of you who develop mobile apps, you realize this is a very, very simple app. It keeps track of, have I taken my medicine? And that seems very simple. This was inspired by a middle school student someone who was probably about, I think about 13 years old, and she was thinking about her grandfather who has Alzheimer's and saying, what can I do to improve his life? So again, the app is very simple, the technology is very simple, but what's not simple is that a 13-year-old girl can say, I, myself, I can make something to improve the life of my grandfather, and not only my grandfather, right, all old people. So I can make a creation where everyone is honoring my grandfather. I did it, right? I did it. I can control this technology and make it work. So again, Farm Alarm shows again, even children can go to their personal experience and feel empowered in this modern world of technology. Here's another one from Hong Kong. Right, this is a middle school in Hong Kong, where again, saying to the middle school students, what can you do? What can you do to improve your community, to improve Hong Kong? And of course, a lot of them think again about old people. They made something called the Dementia Care Companion. And again, it's an app that kind of has one button on it. And if an old person is lost, you can just press the one button that says help, and it has alarms. It tells you where you are. It can alert your family to where you are. There's all kinds of instructions. One of the wonderful things that they did, when you're using this app, the instructions come in the recorded voices of your family members. Right? I think it's that's just a wonderful thing. And there's something there that says, well, gosh, only a middle school student would have thought of doing that. We don't see the commercial apps doing that. But again, it's the notion that these elementary school students can look around them and say, what can I do right now? What can I do to improve my community? And that's very different. You know, we teach about computing, and what do we say to students? We say, well, maybe you want to do it because you're going to get a job, or maybe when you go to university or something, you can study and learn more. This is not that. This is what can you do now? And it's an amazing change in the technology that makes this possible. Right? Even young students can do something to improve the quality of life for their community. This is an MIT version, so this is a little bit more advanced. Do you know about these test strips where you put a sample on it and they light up in different colors? So 3 of my students did a simple application where you take one of those strips, you put a sample on it, you take a picture of it with your cell phone camera. There's some very, very simple image recognition that says where are the different patches and where are the different colors, and given that, the app can automatically create a diagnosis using the information on the strip. And that can be sent over the internet to a clinic. So this was designed by my students for use in developing countries. Right, this is an example of that being tested in a rural clinic in Guatemala. I'm sorry, in Nicaragua. And again, the message here is that even students can make breakthrough technology for medical applications. It's just quite amazing that can have worldwide impact. And again, we're talking about young students. So let me show you, how is it possible that these middle school students can actually create an app? Some of you will know this from the App Inventor, but let me just take a minute and show you what it takes takes to create an app. Here is the interface, the web browser that students are using to create it, and here is what it looks like to have something on the phone. So I create an app, and I select components, and I say I want to select a button. So you select a button, and you drag it onto the screen, and then at that moment, a button appears on the phone. I mean, we've already created a running application that does nothing right now except show a button. But that's how fast you do it. Then you say, oh, I want to add a little bit more. I want to get a picture. I'll put a picture of a cat, and I'll say the button should have the shape of a cat. That's my cat, by the way. And then I add some more. I say I want to put a sound, so I'll come here and put a sound on in the phone, which will be a recording of a cat doing a meow. Right, so again, I've got a real app running on my phone with a button that's a picture of a cat. At the moment, this app does absolutely nothing. Right, I want something to happen. I'd like something to happen when I press that button. So I go over here and I see what are all the things that a button can do. And the first thing that a button can do is you can say, do something when you press the button. So I drag this out, which sort of says, when a button is pressed, do something. And the do something I put on there is I drag another block that says, when the button is pressed, play a sound. And now, at this moment, right now, there's a running application here. And if I press that button, I hear the cat's meow. So that's how hard it is to create an application. I want you to imagine how these young children can build things like that. And then, of course, you can do more sophisticated things. I could add a label. So there's a label. And I could add another thing that senses where my location is. And I add a little bit more to this app that says when you press the button, not only should the cat meow, but that label should show your location. So here it is running again. That's my address. The thing to notice is that something very complicated happened. When you press that button, the phone's GPS found out its latitude and longitude. That latitude and longitude was sent over the internet to a geo server, which looked that up and turned that into an address, which sent it back to the phone. Of course, kids don't see that. They see that you get the location. But I want to give you the sense of there's some rather complicated things that are going on the internet that you can invoke very, very simply. And that's the source. This is a simple example of the source of that power that we can now give kids or anyone. Where are people doing this? We run a server at MIT that's accessible worldwide to everyone. We started in 2013. Since then, we've hosted almost 7.7 million users, almost 8 million users, million individual users who are using this to build apps. And they've built about 24 million apps since then. You can see a list of the numbers from last spring, and from last spring you can see the top countries. Very recently, and look at Taiwan. Taiwan is number 2 in the world of countries building apps. In fact, I checked the numbers this morning and found out that since September 1st, there are almost 80,000 connections to our server. This isn't quite right. It's about 80,000 connections, which represent about 30,000 unique individual users in Taiwan in the last 6 days who are using this. One of the places you don't see on here in this list of countries is China, is mainland China. because you can't get to our MIT server because it's blocked by the Great Firewall. Right? You don't see China at all here. So one of the things we've done, besides putting up our server at MIT, is we're working with the Education Information Center in Guangzhou. They've put up a App Inventor server in Guangzhou that right now has about 300,000 mainland China users who've made about 1 million apps. So that's how people in mainland China can use this. There actually is the center that does that in Guangzhou. It's sponsored by the government of Guangzhou. And again, they say they've got about 1 million projects, and they're making it available in schools throughout China. And it's even part of the official just introduced curriculum for Guangdong in technology. And these numbers must be very, very recent because it was just introduced. So, but that's what they tell me. I can't quite vouch for it because it's too recent. The other thing that's been going on, this is done in cooperation with Google China, is they've had a contest, and again, I want to show you some other computational action things that young students are doing. So this is one of my favorites. This is the high school winner of the contest. These are 2 high school students from Guangzhou, and they are trying to influence the world by helping citizens track pollution, which of course is a major concern. And what they've done is they created, using Internet of Things, some very inexpensive sensors, which do things like track pollutant particles of various sizes. And you can look at the sensors and you can see what the local pollution is like. And notice what they're saying, right? When they present this, they say our theme is "You and Me Change the World." Right? Again, it's about, in this case, 2 high school students in Guangzhou. We can change the world. And not only do they make a local sensor, but they've put up a website. They put up a website that allows you to share the readings from all of the users. Right? Very simple. And it's much better than the sensors that the Chinese government is giving out. Right? Because it's distributed and you can share the information and get it immediately. Again, 2 high school students. The junior high level in that contest, we had some students who created a version of the snake game. They wanted to do something that had hexagonal paths. So that was fun for them. And there's the primary school winners of this Chinese contest. There's the youngest winner. The youngest winner was 10 years old, who created a nice little app about spending the night in the museum and seeing a lot of exhibits. But again, a 10-year-old. We're also working with the Jockey Club in Hong Kong and have a project called Cool Think, whose idea is in a very serious way to put this material, put App Inventor from scratch into the upper primary school curriculum, grades 4, 5, and 6. And that also has a contest. This is from a year ago, last October. So they did a local contest for primary schools involved in this Cool Think project, and they had 86 teams and finalists. And the winning entry was, again, a real story of computational action from this primary school in Hong Kong. And again, it was aimed at helping elderly people suffering from dementia. And it's the same thing. It has a very simple interface, right? This is the interface to the app. You lost it. So again, this is them designing something for an older person who's suffering from dementia who types SOS, I'm lost. and it notifies his family and even can notify people around that there's a person who needs help. And the thing that's really striking to me, that this came out of the direct experience of one of the boys in that class who had a grandfather who got lost and said, gosh, what can I do to deal with this problem that I had such personal experience with? And again, that's a model of computational action. It's about even young kids, even primary school kids, saying, I can use this technology to have an impact on the world, impact on my family, on my grandfather, to have an impact on my city, my country, maybe even to have an impact on the world, and I can do it right now. So the thing I want to say, I said this was for teachers. Teachers realize that over the past few years, and again I think 5 years, none of these projects would have been possible more than 5 years ago because they depend on the communication infrastructure that allows us to put up something that's accessible around the world. Right? That would have been a major research project 10 years ago, and now it's something that primary school kids can do. So for people who are going into teaching with computing and technology, you have an amazing opportunity for the future. Right? You literally can help your students to realize their ambitions to change the world. And the other part to think about is I'm talking about change over the last 5 years. I can't imagine what will be possible to do 5 years from now. And think about who that is. If you're teaching kids who are 15, what are they going to be able to do when they're 20? Right? What kinds of citizens are you creating in this new world of information technology? And what is your opportunity to really show them that they can be leaders, that they can start realizing their visions, not when they grow up, not sometime in the future, but actually right now. So, thank you very much.
Thank you, Professor Abelson.
好了，但是我想感谢他用我们的高铁一路送的。我们正光的董事长，他以前也当过成龙的董事长，那所以他一直在帮助我们这个活动。那现在特别 MIT 的校友赠送给 MIT 的老师
Very honored. Yeah. This we high-speed rail souvenir, but the purpose for this was to try to promote our high-speed rail because we have thousands train set per week, and some off-peak hours only 50% share. So we need the best utilization of the seat. So we combine with our tourism, sightseeing resources like hotel and also the tourism agencies. So we put this one, and also we have this one also have it also in Chinese 搭高铁游台湾。我们希望说呢，把我们一些离峰的座位透过我们跟观光的这个相关产业做异业结盟，这个就是符合我们洪所长、洪院长所推动的这个创意创意行销。所以我用这个 I have this souvenir for you, but I hope, sincerely hope you stay longer to give us a ride, give us the high-speed arrive. So you will feel how the performance or the quality that high-speed rail provide. Okay, because you are a senior, I just need to report to you. I graduated from MIT 1984 from Ocean System Management.
You're a child, right?
Yeah. From C, I joined after graduation there. I joined the Evergreen Marine. In that time, they are the #1 in terms of the world, in terms of carrying capacity. But 6 years later, I joined the airline because our Evergreen group found the EVA. So I joined the airline from the very beginning. So, but a couple of years later, I also joined the high-speed rail because we are one of the founders for high-speed rail. So, but I really want to report to you, as your junior, I do my best to promote our MIT.
Oh, thank you very much.
Wonderful presentation.
好，我们谢谢搭高铁游台湾大家有兴趣多跟我们总经理聊一聊好。OK， yes.
Now let's welcome Professor He Liang-Gui.
会。
The next presentation the chairman.
在这边介绍吗 ？OK， 我的名字叫何桂良，是何良桂。OK， 我是台北市立大学副教授。